Hey everyone, and welcome to the second math library programming tutorial. Last week I know I said that I was going to show you how to make this function right here, which is raise an arbitrary base to an arbitrary power, where we actually allow decimals. But the problem was though doing like this requires a lot of numerical methods, uh, and we don't really need it at the moment. So for that reason, I'm just going to keep it at an integer, and that's also a lot easier to write. So first we need to handle a special case, which is if we're trying to raise 0 to the 0th power. That is undefined. And the short explanation is that 0 to anything is 1, and 0 to anything is 0, and anything to 0 is 1. So we have a clash right there. So sort of throw an exception, that is 0 raised to the 0th power is undefined. Now that we have this, we can start writing this function. So first we're going to check if the power is 0, that's going to return 1. Otherwise, the power is, if it's greater than 0, then we'll return base times the power of 2 . Otherwise, we're going to return 1.0 divided by the base raised to the positive of the power. I'll put a minus sign here because it is that this number is going to be less than 0 by the time it gets to this point. So we flip it to make a positive. And by algebra, if we're taking a negative exponent, we do 1 divided by that. Now we can test it out in main. So we did 2 to the power of, let's try max to 1.1 to the power of 2, and that should give 1.21. Don't worry about this part. And then try 2.0 power of negative 2. So 2 squared normally is 4. And since we're raising to a negative power, if we do 1 divided by 4, so that's going to be 0.25. So we get over here. There's also some other functions that I want to add over here. So one of them is the absolute value function. So let's do it's going to take a double, because we should be able to take an absolute value of anything. And check if it's negative. We're going to make a positive. Otherwise, we'll leave it be. So we can do 1, that should give 1. And we put in an arbitrary value here, that should leave it be. All right, then another function that I want to add, it's a special case of of the power function, and that's just squaring it. So it's good. So, rather than just calling it as a generic power function, I'm going to call it square. I'm going to keep that computation time constant. So the square root algorithm, I know like in the comment section I did write when we do a square root function. Uh, that one I want to save until next week because that one uses an algorithm that most of you aren't really familiar with. That is using Newton's method of approximation. So I'll show you how that works next time. Um, anyways, if you did enjoy this, hit the like button, and if you still want to see more of this, do let me know in the comments. And that's pretty much it. Oh yeah, I do need to. I should mention that if you have any other functions that you want to add, like last time, do do listen in the comment section, and I will also put a note in the description that I will add I will do the square function and the square root function next time. So I'll see you there.